Hello, today we are going to learn about the chapter 4, which is about motion. When you talk about motion, we see objects are in continuous motion. What is motion? Change in position of an object. When an object is moving, it is considered as it is in motion. Whether it is a stationary object like atoms, or a tennis ball, or a space probe, all are in continuous motion. So the study of motion is called as kinematics. And the kinematics involves motion without considering what causes this motion. If I have an object at rest, unless and until some force acts on it, that object does not move. But once it moves, it is in motion. So So, to understand the concept of motion, to better understand the concept of motion, you have to know certain topics in physics, such as displacement, velocity, acceleration, and forces. So, in this chapter, we're going to learn most of these topics. So, if we go to the next slide, development of physics. So if you see in the ancient times, the word motion, it came from a Greek word, wandering, it means. So during Greek time, people used to travel based on their celestial movement of the planets. And that led to the study of motion of the objects on this planet. And since most of the Greek time, the philosophy was called as a natural philosophy, because there was no any scientific studies or scientific approach to those. That's why they are called as natural philosophy. In Galileo, he was considered the father of observational astronomy. He was the first person who used the telescope in 1609 to observe the celestial movement of the bodies. And he was the first person who agreed with Copernicus that planets orbit the sun, and that is called a heliocentric approach. Before that, they always used to think that all planets they orbit around the Earth, and that concept was called as geocentric. And geocentric approach was changed to heliocentric approach. That's why Galileo was considered as the father of modern science, because he is the one who discovered the scientific method. That's why he's called the father of scientific method. He systematically studied the speed, velocity, gravity, projectile motion, and the properties of pendulum, all studied by Galileo. So he was the one, that's why he was considered as father of scientific method. You all know from the chapter 1, scientific method involves a systematic study to understand the mysteries of this world. And this scientific method has transformed modern science. So scientific method involves certain processes. Like first is it involves the formulated by observations. You observe stuff, then you test your observation, you give a tentative explanation, which is hypothesis. Then you test your the hypothesis by experimentation and measurements, and you verify, leading to a firm definition of scientific theory later on. So in this chapter, we're going to learn mainly about certain topics which are called as scalar and vector quantities. Let's see what is a scalar quantity. A scalar quantity only has a magnitude, and it does not have a direction. So, example, I want to give in a mass. Mass has only a numerical value, a number, time, density, length, temperature, speed. All these are scalar quantities. Now, what is a vector quantity? A vector quantity has both magnitude and direction. Those type of quantities are called as vector quantities. Examples: velocity, displacement, direction, force, and momentum. These are called as vector quantities because I can apply a force of certain newtons on an object from a certain direction, and the object moves in the direction of the force. So that's what. So force is a vector quantity. So let's see here. What I'm going to just explain using the this. If you see the track here, I'm going to using that track. I'm going to explain what's the difference between a distance and displacement. As you know from the before slide, distance is a scalar quantity. It has only a magnitude but no direction. So a distance, how do you define distance? Is the total length of the path traveled is called as distance. So if an athlete, if he's starting from the starting point, if each lap is 1/4 of a mile, and if we take 4 laps, so how much distance he has covered? He has covered a total of 1 mile. That's the total distance covered. But when I explain what is displacement means it's the change in position of an object. How do you calculate final position minus initial position? Is called as displacement. So let's see, if this athlete, he started from the starting point and the finish point is on the same place, and if he has run 4 laps and he came back to the original position, what is his displacement? His displacement is 0 because his position did not move. So that change in position is 0, thus his displacement is 0. But what is the total distance he covered was 1 mile. So distance is 1 mile, but displacement is 0. Let's see, what is the difference between speed and velocity? Again, speed is a scalar quantity, whereas velocity is a vector quantity. And now why? Because speed is distance over time. Distance is a scalar quantity and time is also a scalar quantity. So speed is a scalar quantity. It has only magnitude. I can say somebody is driving 20 miles per hour. That's all. That's his speed. 50 miles per hour. It's the speed. But if when I talk about velocity, it's a scalar, it's a vector quantity, and it is displacement over time. And when you are displaced, your direction is also changing. So that change in direction, displacement is a vector quantity. Hence, velocity is a vector quantity. So in this example here, what was his speed? His speed is 6 miles per hour. What was his velocity? It was 0 because displacement was 0. So his total velocity is also 0. So you see this? So velocity is 0. So when you're doing problems involving these concepts, what is the general rules for solving physics problems? First one, you have to draw a diagram to help visualize the situation. It will help you visualize what is the scenario. Then list all the given facts in one column. So if you want to list all the given facts in one column, you have to know the symbols and the units for those quantities. Then you identify and list all the unknowns in another column, like on the side. So then you for unknown, put a question mark. Then find the equations and conversions that might be applicable to that problem and pick accordingly. And then you plug in those values and calculate the unknown values. So these are the systematic steps to do the physics problems. Let's do one example here. A miler covers 1 mile in training at a 6-minute pace, which is 4 laps on a 1/4 mile track. 6-minute pace. So let's say, what is his speed in miles per hour and in meters per second? So let's see. So we need to know the speed. Speed means what? What is it? From the prior slide we learned speed is distance over time. How much is the distance they gave you? They want you to calculate speed in miles per hour. So first question is, did they give you the distance in miles? Yes, a miler cover. How much miles? 1 mile. Then you need to get the time in hours. Did they give you in hours? No, they gave you the time in minutes. So how do you convert 6 minutes to hours? We know there are 60 minutes in 1 hour. So 6 minutes will be 0.1 hours. How did you get that? 6 divided by 60, you get 0.1 hour. So now what do you do? In order to get the speed, I divide 1 divided by 0.1. So when you do that, you'll get the answer in miles per hour. And do the same thing. So now you want to convert meters per second. In order to convert meters per second, you need to know the distance in meters and the time in seconds. In order to convert 1 mile in meters, we know the conversion. 1 mile is equal to 1609 meters. And 6 minutes is equal to 360 seconds. So how did I get that? 1 minute is 60 seconds. So 6 minutes will be 6 times 60, which is 360 seconds. So when you divide 1609 divided by 360, you will get the distance in speed in meters per second. What is the second question part? If the starting line and the finish line are in the same place, what is his displacement? The person did not change in position, didn't happen. So that means what is his displacement? It will be okay. There are next here in this we're going to learn about uniform and accelerated motion. What is a uniform motion? In a uniform motion is a motion in which the speed is constant. At constant speed is called motion is called as uniform motion. If the speed changes, that type of motion is called as accelerated motion or variable motion. There are two types of variable motion. If a speed increases, that is called as accelerated motion. If a speed decreases, when you're coming down the mountain or coming down the ramp, your speed is increasing. That is accelerated motion. But if you're going up the ramp or climbing the mountain, then its speed is decreasing, and that is called as decelerated motion. So these two motions, accelerated and decelerated, comes under variable motion. So let's say before we go into the equations of motions, we need to know the quantities and the symbols, which are very important. Let's see what are the quantities. So first quantity is distance. We know it's a scalar quantity. The symbol is d, and we use the metric units, which is meters. Speed or velocity, the symbol is v, and the units are meters per second. Average velocity is v average, which is again the units is meters per second. Acceleration, the symbol is a, and the units are meters per second square. Time is t, and the units is seconds. All these are metric units. Now let's see what are the equations which are of motion. There are two types of motion. If an object is starting from rest, its initial velocity is 0. In that case, we have to use this part of the equations. If an object is already in motion and coming to a stop or speed is increasing, then you have to use this part of the equation, which is non-zero initial velocities. So these are the equations for zero initial velocity. Distance is equal to v average over times t. That's the one equation. V average is half of the velocity, final velocity. V is equal to a times t. What is a? Is v over t. If you, and for this is last equation is again very important. What is the, if you know the acceleration and if you know the time, what happens when you accelerate your car? It goes to a certain distance. So that distance you can calculate using this equation. D is equal to 1/2 times a times t square. This is the equation for when an object moves from starting from rest. If an object is already in motion and it's coming to a stop or is increasing its speed, then you use these equations. Non-zero initial velocity. Your initial velocity is not zero. Here the distance will be the same equation, v average times t. But v average is equal to, once you know the initial speed and the final speed, you can calculate average is you add them together and divide by 2. You get the average. Now what is v here? V is the final speed or final velocity. V0 is initial velocity. And so if you know the initial velocity and you accelerated your car for a certain time, you can calculate how much is the final velocity. That's what. If you rearrange this equation, you will get this equation, which is a is equal to v minus v0, which is nothing but change in velocity divided by time, is called as acceleration. And therefore the last equation, this is a d is equal to v0 times t plus half at squared, because already an object is in moving, so you have to add that how much is gone. So that's what v0 times t, which is the distance moved. Then you add the second distance. So total distance is, an object is already in motion, so you have to use this equation. Say v average is used for speed or velocity that is maintained at an average value. Units are all metric units. You have to use all metric units. If you want to convert somewhere, you need conversion, you need to convert to metric units. So these are the two types of uniform and accelerated motions, which again, these are all the equations. Zero initial velocity, object is starting from rest, accelerating from rest. Your initial velocity is 0, and these are the equations you're going to use. For an object which is non-zero initial velocity, object not from rest, it's not starting from rest, initial velocity is not 0, equal to, and these are the equations you're going to use. v0 means initial velocity is not 0. So a is equal to change in velocity over time. So we're going to use these equations and we're going to do certain problems. In the Blackboard, I'm going to upload some of the examples already worked by one of my colleagues, and I'm going to upload that in the Blackboard as an attachment as well. Let's see, what are the steps for solving problems in these equations? Most all these equations require metric units. First, read the problem and convert any values to metric units if necessary. If I give you in miles per hour, convert into meters per second. So assign proper symbols to each quantity. Like distance is d, time is t, and acceleration is a. Initial velocity is v0, final velocity is v. So when you know those, you just assign those proper symbols. Then select an equation containing these symbols. Then place the values of the known in that equation and calculate the unknown equation. So that is the systematic way of doing the physics problem. Let's do one example. Starting from rest, an automobile accelerates to 60 miles per hour, starting in 8 seconds. So starting from rest means which equation I should follow? Zero initial velocity or non-zero initial velocity? It should be zero initial velocity. So, and what is its acceleration and how far it has gone? How far means what? Distance. So they're asking you A and they're asking you D. So for that you need to know certain certain known quantities. So let's see, from this equation, from this problem, what are the things they gave you? 60 miles per hour, that's the speed they gave you, that's v, because it's starting from rest. That means what is its initial velocity? It's 0. So whatever velocity is the final v is 60 miles per hour. But I need to convert that 60 miles per hour into what? I need to convert into meters per second. So how do you convert that meters per? They convert, you might see, we know the conversion. 1 mile per hour is 0.447 meters per second. So 60 will be, you multiply 60 times 0.447. So you will get the answer. That's your v. Then what is 8 seconds corresponds to time. So you got v and you got t. So how do you calculate a? We know the equation from non-zero initial velocity, that a is equal to v over t, right? So you divide whatever number you get after you convert to meters per second, you divide by 8, you will get the answer of acceleration. And once you know the acceleration, you already have the time. You can substitute in equation for distance is equal to 1/2 a times t square. When you plug in those in that equation, you will get the answer for distance, and the units will be meters. So this is so these are the equations we're going to follow. See, these are the two equations. We're going to use this equation and we're going to use this equation to get meters. Okay, there is one more equation here also. You can follow the same procedure and you can do the same problem. So these are general word problems, and for all these, some of the word problems, my colleague, I am attaching a blackboard links where you can find how to solve those. There are certain practice problems, so all these practice problems are involved. Say this is also moving, comes to a stop, and distance of 50. How much time is required to bring to a stop, and what is its deceleration? So here you see this is the equation they gave you. An automobile moving at 13 meters per second. That's the initial speed, and it comes to a stop. That means its final speed is 0, and in a distance of 50 meters. So if you know the acceleration, so well, they didn't give you the acceleration, but you know what will be the, they gave you the distance and they gave you the initial speed, and the final speed is 0. So from there, can you calculate the time? Can you calculate the v average first? So what is v average? You add the initial speed and the final speed and you divide by 2, you get the v average. Once you got the v average and you got the distance, can you calculate the time? Yes, you can use the first equation. D is equal to v average times t. You can calculate the distance. And once you know the distance and you know the then let's see, where did they give you the acceleration? They didn't give you the acceleration. Then you got the distance and you got the time. From here you can calculate the acceleration, that which will be deceleration. So again, these are the equations for non-zero initial velocity. Non-zero initial velocity is when an object is not starting from rest. So these are the equations we're going to use. So in the earlier case, we are going to get these equations. So this is the we're going to plug in these equations. We can get the answer for the problem which was in the earlier slide. Non-zero velocity problem. These are some of the examples of a non-zero velocity problem. A rocket-propelled sled was used to explore human limits of acceleration. The sled reached a speed of 632 miles per hour. So you need to convert this into meters per second. And then it stopped. That means its final speed is 0. So you got the initial speed, you got the final speed. Can you calculate the v average? Yes, you divide this plus 0. Whatever you get meters per second, you add to plus 0, divide by 2, you get the v average. And then once you got the v average, what is its deceleration? So deceleration means so we know that We know the acceleration is, that's the initial speed, right? So we know the acceleration is equal to v minus v0 divided by t. So what is this final? So what is the a is you use the equation a is equal to v minus v0 divided by t. So here v is equal to final speed, which is 0. What was the initial speed? Whatever you multiply this times 0.447, you get in meters per second. Put that value there and you divide by 0.624, and when you do that you will get the answer for acceleration. And once you get the acceleration value, you divide by 9.8, you'll get the units of g. So what is the chapter summary of chapter 4 is, once you decide, so we have, there are, when you, what type of problem is it? Is it a zero initial velocity or is it a non-zero initial? And then convert the known units into metric units, and then convert. Then once you convert, then you look for the equations and you plug in those known values, known given variables, and you calculate for the unknown. So this is the for part A, and then I have a part B I will give you in another PowerPoint slide. So according to the Greek theory on gravity, as we know, most of the Greek thinking was about natural philosophy, and according to the Greek theory of gravity, they postulated that heavier objects will fall to the ground faster, fell faster than the lighter objects. So this concept was stated that according to that postulate, it means that the heavier objects possess more gravity, and the earth was as their natural resting place. That's why they are falling to the ground. This was the earlier explanation why objects are falling to the ground. And this theory was based on the earth being at the rest and the universe is circling around the earth, which was geocentric approach. And later on, Galileo later disproved these theories some 1900 years later. So Galileo, what he did, he was an Italian scientist, and he's the one who gave the laws of free fall. And what he did experiments, and since he did this, he was the father of scientific method. So he really proved that doing some certain experiments, scientific approaches to his free fall. So what he did, he went to the Leaning Tower Pizza experiment, where he took two balls of different masses and dropped, and he found out that both the balls of different masses, they fall on the ground at the same time. That means the rate of falling was same. And he also did on ramps and free fall, and he also proved that balls of different masses used, the time and speed of these balls were same, and steepness of the ramp did not affect the speed. So that means according to his experiments, he proved that irrespective of what masses an object has, all objects fall to the ground at the same rate. And this is only happens when you remove the air resistance. When you consider air resistance, the objects fall with a different rate. I'll give you an example. If I have a heavier object and a paper, a blank paper, if you drop to a certain height, obviously the heavier object will come down first. The paper will come later. That is because the paper is under the influence of greater air resistance. But if you take the paper and made it into a ball, ward it off and make into a ball, and then you drop the same two objects, the heavier object and the wadded paper, and you from a certain height, and you will observe that both will hit the ground at the same time. And now why the same paper, which was not wadded up before, and now it's wadded into a ball, why that both hitting the ground because when you're making the paper into a ball shape, you're decreasing actually the air resistance, and all objects fall to the ground at the same rate when there is no air resistance. Yeah. So these are the two experiments he did. Same thing with that's what called as a free fall. That fall, which is so. What is a free fall? When motions of objects falling straight down due to gravity is called as a free fall. When you're dropping from a certain height, if the fall is influenced by gravity, and that fall is called as a free fall. And you know that the rate at which it is pulled to the ground, and that is called acceleration due to gravity, same rate. So that is 9.8 meters per second square. So air resistance is not taken into account in free fall. And zero velocity equations have to be used. Why? Because when you're dropping an object from a certain height, you're starting from rest. So its initial velocity is zero. And equations wherever you use substitute acceleration for. So you had a, wherever equations you had a, you need to substitute the a with a g, and the corresponding equations, if you see, v is equal to g times t. That's the velocity, gravity times t. So if you know the time of the fall, you can, if you multiply with gravity, you get the velocity, how fast, what is the speed. Same thing with, if you know the gravity and the time of the fall, you can calculate the distance of the fall. Or if you know the distance of the fall or the height of the fall, and if you know the gravity, you know g is always 9.8, you can calculate the time it took to hit the ground. So how do you calculate that? You can, if you rearrange this equation, excuse me, if you rearrange this equation, this the time is equal to, it becomes time is equal to 2 times d divided by g. That's the square root of that. So t square is equal to 2d over g, and if I want only t, you do the square root of 2d over g. So if you do the first example, I'm going to show you, explain how you do the first problem, and then once you, and some of the actually worked problems is, I'm going to attach a YouTube video from one of my colleagues who solved most of the problems, and she clearly explains how to do the free fall examples when you're doing the problems. So let's see, a diver goes off a 30-meter high cliff. That means they gave you the distance in 30 meters. You make sure everything is in meters, which is the metric unit. What is the diver's time in the air until their contact with the water surface, and how fast are they going at this time? First thing, so they're asking two things. One is the time of the time it took to fall, and second one is the velocity. So we know from the equation earlier, velocity is equal to g times t. So for that you need to know the time. So right now I don't know the time. So how do you calculate the time? So you need to know, you have to use this d is equal to 1/2 at square. So which is a is replaced with g, which is called a gt square then. So if I want, so how do you calculate the time? When you rearrange that equation, you will get the equation for time is equal to square root of 2 times the distance. What is the distance they gave you? 30 meters. You divide by 9.8, and when you solve it, you get the time. And once you got the time and you multiply with acceleration due to gravity, you will get the velocity, the speed. And the other examples are also worked out. You can follow, and then you can work out in a similar way. Now, what is the next type of motion is called as a projectile motion. What is a projectile motion? Projectile motion is a motion of an object that moves along a trajectory path. That means this is the type of motion which includes both, which combines both the horizontal motion, that means going in a straight line, and then coming down, and it includes the free fall. So this type of, that's why according to Galileo, he defined the critical concept that the motion is simultaneously horizontal and vertical. That's what is called as a projectile motion. So in projectile motion, air resistance is not taken into account. Same thing. And combines horizontal motion with a downward motion. And here both the motion, horizontal motion and the vertical motion, are independent to each other. They are not dependent on anyone. Now, what are the examples? A punted football, or an arrow when it is released, and or a bullet shot. All these are examples of a projectile. So I will give you. So this is very important for quiz and test, where they say that if I drop a ball and if I shot a ball, which one hits the ground first? They both will hit the ground at the same time, same rate. You see, initially this has there is no influence of there is no, here in the horizontal there is no air resistance, so it free fall, it hit the ground. Whereas if it's when a ball is shot, it takes a trajectory path. So initially the horizontal motion is irrespective of, it has no influence of gravity. Then it is gravity is pulling it down. So then, but they both are hitting the ground at the same time. So gravity affects the projectile motion and the free fall in the same way. Projectile motion and the free fall, gravity. If an object is thrown and dropped at the same time, they will hit the ground at the same time. This is an important point. When I throw a ball and I drop a ball, both will hit the ground at the same time. So if you see the characteristic of projectile motion, gravity is the only force that is acting upon the object. And object travels with a parabolic trajectory. It's going like a parabolic trajectory, and possesses a launch angle in the apex. Apex is the height of this. Here it's called an apex, and there's an angle. What are the characteristics of a projectile motion? No horizontal forces acting on the object. There is no horizontal forces acting on the object, and horizontal velocity is constant. There is a vertical acceleration due to gravity. This is the most important point. The horizontal and the vertical motion of a projectile are independent of each other. The horizontal motion and the vertical motion both are independent of each other in a projectile motion. Let's do now. So let's see what is vector plot. How can you express a vector space? So what is a vector? So we know vector means it has a magnitude and direction. So a vector is represented by a red arrow. This is a vector. So if you have a vector is always shown by an arrow. This is the tail of the arrow. This is the head of the arrow. If I have two vectors, one is on the east side, one is going on north side, how can I add the two vectors? But so I cannot add two vectors with the tail to tail. Always vectors are added with the tail of the one vector is added to the head of the other vector. So how can I add these two vectors? So if I take this green vector and pull it all the way and place it here, and this, then I can, that means what, the tail of this vector is adding to the head of this vector. And now you see now what you do, you connect the head of this vector here and to the tail of this vector. That is called as a resultant vector, A. So, and this theta is the angle of the direction angle. So if theta is, and what is AX? AX is the distance along the east direction. AY is denoted for the Y direction, which is north. North is denoted by AY, and this is the resultant. A is the resultant. So in a vector length direction are given. So if you have to know 4 equations here to do the vector problems. First one, if you know A, which is in the direction of, so if this is the direction east, this is north. What is A? A is in the northeast direction, and this is the angle is theta. So you see now, this is northeast means it's equally north and equally east. That is northeast, which is 45 degrees angle, and this will be, because this whole thing is 90 degrees. So when you divide it by half, this is 45 and this will be 45. So how do you assign the sides? Anything which is going towards east is AX. Anything goes towards the north, which will be AY. So if you know if you know A and theta, how can you calculate AX? This is the equation. A cosine theta. AY is the direction towards north, which is A sine theta. So these are the terms. If x and y are components given, if they gave you x and they gave you y, how do you get A? You get A by using ax square, Pythagorean theorem, which is square root of ax square plus ay square. That's the Pythagorean theorem. Now, how do you calculate the theta? So if you know ax and if you know ay, how do you calculate the Pythagorean theorem? So according to Pythagorean theorem, theta is equal to secant tan or tan inverse y component divided by x component. That's what is this. So, but when you are doing this, make sure your calculator is on a degree mode to calculate the angles. Make sure that is always important. So the terms which are used for in vector problems, these are the terms which are used in vector problem. Horizontal or due east is x direction. Vertical or due north is y axis, y direction. And the direction is given by an angle theta. If I say when angle theta, so if I say north of east means you go counterclockwise direction. This is the angle. If I say east of north, towards east of north, you say start at the y-axis and move the counterclockwise. So this is the, so east of north is this, north of east is this direction. Now, what is if I say northeast, then this will be 45 and this will be 45. Okay, northeast means equally north and equally east. That's northeast directions. So let's do one example here. In a vector problem, so you see, you walk 3 miles in the direction that is 40 degrees north of east. That means they gave you 40 degrees north of east. That means your A is given. How much? 3 miles A. And what is the angle theta given? 40 degrees north of east means you go counterclockwise. So that the angle is 40 degrees north of east. How far east and how far north you've got? So they gave you A and they gave you theta. How do you calculate AX? AX is equal to A cosine theta. So when you do, plug that number and you will get the answer. How do you calculate how far north you've gone? So that is AY. That is what A sine theta. That's all. So AY is equal to A sine theta. Sine theta. So when you then calculate, so if they gave you A and theta, you can calculate AX and AY. But if they did not give you theta and A, how do you calculate from X and Y? So you can calculate using the Pythagorean theorem, you can calculate A, and by using the angle equation, theta is equal to tan inverse Y over X, you can calculate theta. So these are very important. So you draw the diagram with X and Y axis, fill the information here, figure out what the question is asking. Remember, X axis is east, Y axis is north. Pick an appropriate equation and solve them. AX is equal to A cosine theta, AY is equal to A sine theta. So these are the examples. I'm attaching one of the YouTube channel video where one of my colleagues is explaining how to solve these type of problems. And what are the general rules for all the physics problems? You do the same thing. Draw a diagram to help visualize the situation. list all the given facts in one column, then identify and list all the unknowns and the knowns, and you plug the unknowns and look for the equation which has all those looking variables, and then you plug those knowns and calculate the unknowns.